What we're going to be doing here is we're going to be solving this problem here, number 4, with quantity discounts. All right, so the setup here is that our annual demand is 5,000 units. The holding cost is 20% of the value, and the cost of placing an order or setup is $50. And if we just buy a small quantity, the price is $10. If we buy at least 500, the price drops significantly down to $8.50. And then if we place an even larger order, we get a small additional decrease. So what we're going to do is we are going to start out by considering the price of $8.40. We're going to calculate the EOQ. And if the EOQ is larger than 2,000, and it was 3,000, that would have to be the answer. Because at the EOQ, we have minimized the ordering and holding costs, and it's the cheapest possible price per unit. So that would have to be the best answer. Nothing could possibly be better. Considering ordering and holding and cost of goods, nothing could be cheaper than that. Now, as we're going to see, the EOQ is not going to turn out to be bigger than 2,000. So what we will do is we will say, okay, let's look at the next cheapest price, the $8.50. And we're going to calculate the EOQ at, and we're going to see that the EOQ for that is large enough that it falls in this range of 500 to 2,000. So because that EOQ falls in this range, we don't have to calculate an EOQ for the price of $10, because why would we want to? The quantity between 500 and 2,000, we're minimizing ordering and holding costs, and we're getting a price of $8.50. There's no possible scenario where you could imagine that paying $10, paying $1.50 more could actually save you money overall. So by using the EOQs, we will figure out the quantities we're interested in. So we're going to have an EOQ that's going to be in this range as one option. And then the other option is to just go ahead and buy 2,000 and see if that ends up being worthwhile. Because we get a little more discount, so is it worthwhile? So that is what we're going to see here. All right, so switch over to my other device here and name that tune. So, this all revolves around, let's see here. It seems weird when I'm recording and I'm not kind of looking at here. And if we use the camera on the tablet, we'd just be looking at sailing stuff. So, with EOQ, any of these EOQ related problems, the important thing is 2 times annual demand times the setup cost divided by the cost per unit times the inventory holding cost. So we're going to take the square root of that, see what we end up with. So like I said, we have annual demand, 5,000 units. The cost of placing an order is $50, and the interest rate, that's an I, can't tell, lowercase I, is 20%. So the first one we're going to consider is the price of cheapest possible price, which is $8.40. So we'll have 2 times the demand, 5,000 times ordering costs of $50, and divide that by 0.2 times the cost, which is $8.40. So we will see what that is. So we have 2 times 1,000 times 50 divided by 0.2 divided by 8.4 is some big ugly number. Take the square root and we get 546. We'll round it to the closest. Round it to the closest integer. That's a 5. $5.46. Okay, so the terms of the offer that our supplier is providing us is that we only get this price, $8.40, if we buy at least 2,000 units at a time. Obviously, buying 546 is not enough to get that discount. So in a few minutes, we are going to investigate the total costs. Oh, what happened here? Total cost, that's why my hand can't touch the panel here. So if the cost, so the cost is $8.40, and let's change colors here. And we can't use this EOQ. We're going to look at the cost of buying 2,000 units at a time, because that's what we got to do to get this price of $8.40. Okay, so that was our first iteration, our first step on this problem. And like I said a minute ago, if the 546 would have been bigger than 2,000, we could stop taking EOQ calculations. But it wasn't, so we're going to go to the next cheapest price. So now this will be, the cost is $8.50, and all the other numbers are the same. So we'll have 2 times 5,000 times 50 divided by 0.2 times 8.5. So when we punch that in our calculator, we should end up with 542. Now, our supplier says we have to buy between 500 and 1999 to get that price, and obviously 542 fits in that range. So the next calculation we will do is we will look at the total cost, and Q equals 542, and the cost is 850. And because 542 was inside that range, there's, like I said before, no reason to go on and look at the next cheapest price, which would be $10. So we only need to do 2 EOQ calculations. All right, so let me another whiteboard screen going here. So like I said, we are going to look at the total costs under these 2 scenarios. And the cost formula we will use is the total cost of an order size Q. Where we'll have holding cost. So we have an interest rate times the cost per unit. I don't know why I can't. I have an I. Times the order size that we're looking at, Q, divided by 2. And then we'll have the cost of placing the orders, the setup cost for each order, times B divided by Q. B divided by Q together, that gives us the total number of orders we place per year. And then we have the cost of the stuff, the cost of the goods. So the cost per unit times the annual demand, not times the cost, the Q, but times the annual demand, because this part here is the total cost for the year of all the units that we're going to buy. All right, so first step was when the cost is $8.40. My writing looks like an angry third grader. My apologies. So the cost is $8.40, and we buy 2,000 units at a time. So our interest rate is 0.2. The cost is 8.4. The order size is 2,000 divided by 2. And then we have a cost of placing an order is $50. And annual demand is 5,000. And we divide by the order size of 2,000. So that's the cost of ordering. And then lastly, we have the cost per unit of $8.40 times 2,000. All right, so if we take 0.2 times 8.4 times 2,000 divided by 2, obviously multiplying 5,000, so we get holding costs of 1,680. And then the ordering cost, we have 5,000 divided by 2,000, that's just 2.5. 2.5 times 50 is 125. And then the cost of the goods, we have 8.4 times 2,000, so that's 16,800. So adding those all up, you get a total prize package of 18,605. So that, wait a minute. No. See, you might have been thinking to yourself, no, that's not right. What is he doing? What is he doing? What is he doing? I was multiplying by the order size Q when, like I cautioned you, we want to multiply by the demand, the number of units we're going to buy over the course of the year. And the demand, and by the way, this is like a plus sign, a multiplication symbol. So 8.5 times 5,000 units. So I also need to delete that part. Let's try this again. The cost of the goods is 8.4 times 5,000 units. That's $42,000. So we have $42,000 plus 125 plus 1680 is 43,805. All right, that is the cost of buying 2,000 units at a time at a price of $840. All right, so now we're going to look at the next cheapest price, which was the price of $850, and we have an EOQ of 542. So we're going to buy 542 units at a price of $850. So the interest rate is again 0.2. The cost is 8.5 now. And then the order size is 542, 5.2. And then we have a cost place of order of $50. Let's play that by annual demand of 5,000 and divide by the order size. 542, and then lastly a price of 850 times 5,000. All right, so 0.2 times 8.5 times 542 divided by 2 is 460. .7. And then we have the cost of ordering is 5,000 divided by 542 times 50 is 461.25. And then we have 8.5 times 5,000 is 42,500. So we get the total price package of 461.25. 42.5 is 43,421.95. So looking at the total cost, obviously the total cost of 43,400 is cheaper than 43,800. So this is our winner. Winner chicken dinner. 43,000, and so we want to buy 542 at a time, and we will pay a price of $850. So last, I just want to point out a couple of things. When we were using this EOQ, the 542, we have rounded the EOQ slightly, which is why this holding cost and this ordering cost, they're not exactly the same, but they're pretty much the same. I mean, they're 25, 30 cents on either side of $461. So they're very closely balanced. as opposed to here when we had to round things up to 2,000, we have holding costs of 1,600 and ordering costs of 125. Those are two are way out of whack, very far apart from being balanced. And then, but when we were using the EOQ here, the lower one, they were balanced. So then the last thing I just want to point out is the differences in the numbers in the formulas. So we have the price of goods is $8.40 on the first calculation. On the second calculation, it's different. The price is $8.50. And then the other thing that's different is the quantity. So we have the quantity 2,000 units here, quantity 2,000 units here. Down here, it's 542 and 542. So those two amounts, the order size and the price, change between the two different formulas, but all the rest of things stay the same. 0.2 is the same, 2 is the same, 50 is the same, 5,000 is the same, 5,000 is the same. So not a lot changes between the two. So then, yeah, just to recap, our decision is to buy 542 units at a price of $8.50, and we will pay $43,421 as our total. So that's our final answer. So I hope this was useful.